Example 1 asks us to assume that $2,000 was invested at a 10% annual rate. Okay, so P is our initial investment, that's $2,000, and our annual rate of interest is 10%, so that's 0.10. And we want to determine the value of the account after 5 years. First off, if simple interest is used, and then if interest is compounded annually. So, for simple interest, we just use the standard simple interest formula. A equals P times 1 plus R T. So, using that, I get that A is equal to $2,000 times 1 plus the interest rate times 5. And then calculating all of this, I get $3,000. You could also, with the numbers on this problem are fairly nice, so you could actually sort of reason through this without using the formula. Since the interest rate is 10% and the initial loan amount was $2,000, we would have to, the amount of interest that would be collected each year would be 10% of $2,000, which would be $200. So the person who invested this money is going to be earning $200 in interest every year, year after year, for 5 years. That's a total of $1,000 worth of interest. So the initial $2,000 plus the $1,000 in interest is going to give $3,000 total at the end of 5 years. Now, one defining characteristic of simple interest is that amount of interest that is paid never changes. It's going to be $200 year after year after year. Even though the balance or the value of the account is increasing every year, interest is always based on the initial principal amount when you are using simple interest. In contrast, if you're using compound interest, the interest you earn gets added to your principal and then begins to collect interest itself. So let me show you how that works. In part B, I want to know how much the account would be worth if we use compound interest, compounding annually. So, ultimately, we're going to have a formula for this that we can use, but just to help you understand what's going on, let me draw a diagram. Okay, so we're going to have 5 years. The initial value of the account is, let me back up just a little bit. The initial value of the account is $2,000. So I'm going to put $2,000 right here. Over the course of the first year, we're going to earn 10% of interest, in 10% in interest. So that's going to give us an additional $200. That gets added to our principal. So now our account is worth $2,200. Over the course of the next year, we're going to earn 10% again, but not 10% of the original principal amount, 10% of the new balance. So we're going to add $220. Okay, so now the account is going to be worth $2,420. Continuing on in this manner, year after year, we earn 10% on the current balance, and then that gets added to the balance, which we'll then earn interest on again. So we're going to go ahead and calculate each of these out by hand, although in the future we're going to have a formula that we can use that will allow us to calculate any of these balances without calculating all of the ones prior to it. So this is actually plus 10% of 2928.2 is $292.82. And then if I add that to the balance, I'm going to end up with $3,221.02. So this is the answer. And you can see that with compound interest, we end up with more money than we did with simple interest, which you should expect to occur because with compound interest, you're actually earning interest on your interest, which is not the case with simple interest. Okay, now if you look at the notes or the book, you'll see that we have this formula for compound interest that says A equals P times 1 plus I to the n, where I is equal to the annual rate divided by the number of compounding periods, and n is the number of years times the number of compounding periods. Now, we're going to talk more about this quantity m in the next example, but for now, here's what we need to notice. Okay, P is our initial amount invested. That's $2,000. We want to know what A is. We don't already. We know the annual interest rate is 10%. And then the amount of time is 5 years. M is the number of compounding periods per year, which if we are compounding annually, like we are in this example, M is going to be 1. So I is the interest rate, the annual interest rate divided by the number of compounding periods. In this case, taking the annual rate and dividing by 1, I just get that annual rate again. N, in general, is the number of compounding periods. So just as an example, if we were compounding 12 times a year, or in other words, if we're compounding monthly, then we would have a total of 60 compounding periods in 5 years. We're not. We're working annually, so in 5 years, you get 5 years. Okay, so now plugging all of this into this formula, we get the following. A equals 2,000 times 1 plus I, so that's 1.1, raised to the 5th power. Then if you plug that into the calculator, you're going to get $3,221.05. So you can see that using this formula, we're able to get the answer. We're able to figure out what the balance of the account is after 5 years without having to calculate the balance after 1, 2, 3, and 4 years.